Hello, and thank you all for attending our webinar about STREETSMART. My name is Josh Evans, the STREETSMART Product Specialist. Today we'll be discussing what is STREETSMART, what are some of the common uses of STREETSMART, and then we're going to walk through using STREETSMART for a real-life scenario. STREETSMART is a congestion management technology that allows traffic managers to see past the intersection to better understand the flow of traffic. STREETSMART uses Wi-Fi signals to report travel time, speed, and even origin destination data back to our customers. How exactly does it work? Do you have Wi-Fi at your home or in your office? Most people connect their phone or tablet to Wi-Fi networks so they don't run over on their cell phone's data plan. The majority of people never turn their Wi-Fi off when they leave their home or office, and your phone is constantly sending out pings to find the network that you've connected with before. Every ping has a unique identifier for the device called a MAC address. STREETSMART listens to those pings and then takes the MAC address and creates a unique number to protect the individual's privacy. As that device passes other STREETSMART sensors, the same thing happens again. We compile the data from multiple sensors and report back how long it took the device to get from point A to point B. That's your travel time. Here are some of the common real-world applications that STREETSMART can be used for. Identifying problem areas of existing roadways. Know the key areas to address with data to back up any proposals. We're going to demonstrate this today. Corridor studies. STREETSMART gives you the insight needed to better understand corridors. Return on investment validation. Prove the benefit and enhancements to a roadway with before and after data, including travel time. Origin destination. STREETSMART allows you to see where people are coming from and at what segment they enter the roadway. New development impact. What kind of strain does a new shopping mall or attraction put on the surrounding roadways? Does it create new capacity concerns on alternate or parallel routes? Peak usage alerts. STREETSMART can notify the traffic manager when congestion delays reach a set threshold. Now let's go over a real-world scenario of how STREETSMART can help and how STREETSMART can help solve common issues. So I'm a traffic manager enjoying my morning coffee. The phone rings with an angry owner of a local restaurant complaining that bad traffic is affecting his lunchtime business. He says his customers complain about how long it takes to get there and back to their office after lunch. Let's jump into STREETSMART dashboard and see if there might be any opportunities to improve travel time around this man's restaurant.
First, we want to see how long is the travel time for this route. This is kind of like getting your blood pressure taken when you visit the doctor. It will give us some insight on if congestion is affecting this route. Since travel time is based on a direction, we'll need to look at travel time from both directions. Let's take a look at the westbound travel times. Notice every day during lunch, there is a dramatic increase in the time it takes to get through the corridor. Now we've added the eastbound travel times. Notice how there's not the same increase as there is with westbound travel times on the same route. This tells us that westbound travel times are definitely something of concern, and we probably don't need to focus too much more on the eastbound direction of this route. Now that we've identified that there is a concern for westbound traffic along this route, let's use another report to help better identify where exactly along this route congestion is the biggest problem. Now that we've noticed this route's travel time increases at lunchtime, let's use another report in STREETSMART to see if there's a part of this route that is feeling the congestion the most. The travel time by segment report will show us the average time it takes to travel each segment. On this report, there are only two segments: North Shore to Paper Mill along Kingston Pike and Paper Mill to Morrell along Kingston Pike. The first segment we're going to look at is from North Shore to Paper Mill along Kingston Pike. On the graph, that's the green line on the bottom. While there's an increase in travel time during lunch, it's relatively flat versus the overall time increase. This shows us this segment isn't as congested as the other segments along this route. Now we look at the second segment, which is from Paper Mill to Morrell along Kingston Pike. we can see a dramatic increase in travel time during lunch. This tells us that this segment is where the most lunchtime congestion is happening. After doing a little research, I found that this area has more than 30 places to eat along Kingston Pike. This explains why there's such a large uptick in traffic during the lunchtime. Since we have narrowed down which segment is most impacted, we can use StreetSmart's origin and destination tool to better understand the flow of traffic onto this segment. The origin destination report is using the StreetSmart sensors that are upstream to show us which sensor was the first sensor a car drove by prior to reaching the destination sensor. We have a destination because we know that the segment ends at Morrell and Kingston Pike looking westbound. We can use that intersection as the destination. When we look at this report, we can see that between the paper mill and Kingston Pike sensor and the paper mill and Interstate 40 sensor, nearly 2/3 of the flow of traffic is entering this segment at the paper mill and Kingston Pike intersection. This shows us three things. 2/3 of all the traffic entering this segment that we're looking at is turning on to Kingston Pike from paper mill. The second is, knowing this intersection well, most of this traffic is turning right from paper mill to Kingston Pike. The third thing it shows us is it makes sense why the first segment's travel time wasn't affected as much as this segment was. Now we can use StreetSmart to see if there's a need to adjust signal timing to accommodate for this congestion. Now that we have a better picture of how traffic is flowing onto this segment, we're going to use StreetSmart to see the average time it takes to enter and to exit this segment. This is going to help us better understand if there is an opportunity to adjust signal timing to reduce the congestion of this segment. Let's start with this intersection at Kingston Pike and Paper Mill. Since we know nearly 2/3 of the traffic is turning onto this segment from Paper Mill Drive, we can use the delay by movement report to see how long it takes on average for that to happen. What we can see is that it takes an average of 22 seconds for a car to make the right turn onto the segment we are looking at today. Let's use this intersection to get an idea of how long it takes to exit the segment we have been investigating. We will see that it takes on average 48 seconds for a car to leave this intersection. Let's recap and see what all we have discovered using StreetSmart.
So to recap, we're looking at lunchtime congestion is mostly impacting only the westbound direction. Most of the delays are contained in the segment from Paper Mill to Morrell Road. We learned that 2/3 of all traffic is entering the corridor at the Paper Mill Road intersection. It takes 4 times as long, or 48 seconds, for the average car to leave the segment, whereas it only takes 22 seconds to enter the segment. This gives us a clear recommendation to adjust the signal timing to allow cars to exit the segment quicker, and also use StreetSmart to verify that the adjustments we make are going to impact the overall travel time of this segment. Now we're going to open it up for questions or any comments based on this, and please use the chat to submit any questions that you may have. Also, feel free to reach out to me at josh.evans@gridsmart.com for any questions or potentially a one-on-one demo of the StreetSmart product. Do you have any questions that you'd like to ask? Feel free to type those in the chat. Okay, so Nicholas asked, does StreetSmart require any additional hardware other than the existing StreetSmart controller? The answer to that question is yes. StreetSmart does use its own controller. It's sensor that goes into the cabinet. It's really small, about 9 inches length by 6 inches width, and about 2 inches tall. So really small, easy to use. Use a standard AC plug. Okay, it looks like Jack asked, is StreetSmart and only TS2 CPU? Jack, do you mind to elaborate a little bit more on that question? Okay, so Denny's asked, what locations is this implemented and being utilized? These are spread throughout the entire United States. There's not really a a specific area. These units are being used in multiple cities, all over. So hope that helps with that. Next question. So is the vehicle detection system are based on personal cell phone signals? It's not actually using the cell phone. It's actually using the Wi-Fi signal. It's something that is quite common, and we see a very large sample rate of the overall commuters on the roadways. So it is using the cell phone signal, using the Wi-Fi from smartphones and tablets that are traveling down the roadway. Okay, so the next question Jody asked was, what are the components of the data collection and analysis equipment? There's actually the StreetSmart device, and it also has an antenna, which actually listens for the Wi-Fi signal. And then from there, the information is coded like we talked about and transmitted to the StreetSmart dashboard where the reporting is taking place. There is a brief documentation of StreetSmart, and that is available from our website, gridsmart.com. And if you look under products for StreetSmart, there is a general document which has specifications, but then also a little bit more information about it. I can also put a link to that here on this channel. So Jack is asking TS2 CPU or the old type CPU. And to answer that question, it's actually its own CPU. And so this is its own device. So I hope that answers that for you. Okay, Stephen asked, installation and setup procedures. Can a customer use their own servers for data collection crunching instead of GRIDSMART Cyclica servers? Can we use customer network for data transport, or is cellular based only? Okay, so first off, installation and setup procedures, not to get too complicated with it, but the unit can be configured away from the actual site. And then installation would simply be installing the antenna and plugging in the device, and then attaching. And to answer your question about is it cellular or customer network, you can use an Ethernet connection for this device, or you can also use a cellular modem. And so the answer there is it works either way. Attaching one of those two to give it connection to share the information. And then, yes, you can use your own servers for, you can have the data transfer to your servers instead of using the dashboard using API. So Denny's next question is it based on Wi-Fi, and how accurate would the percentage of origin be? Not every vehicle. I'm not sure as far as percentage of origin and what you're asking there, Denny's. Potentially, you know, I'm not really sure what you're asking for there. Now, what's really awesome about Wi-Fi and why it's such a great method to use is because with Wi-Fi, you can actually use signal strength to help better identify the location of the device in relation to the StreetSMART sensor that's installed at that intersection. So that gives us the ability to also, using StreetSMART, use vehicle speed. And thank you, Daniel. Daniel actually just chimed in too and said that we expect roughly 40 to 60% of devices that travel past a sensor. Okay, so what is the detection range of the sensor you described? You know, it's going to vary based on a lot of factors. So that would just depend on the environment. I don't want to give a number per se on what the average, you know, detection is. You know, for Wi-Fi as a whole, you know, the average range for Wi-Fi is going to be somewhere around 150 feet. But once again, there's a lot of factors that vary. In an open environment, that could be double that. In an area where there's a lot of obstructions, it could be less than that. So you know, there's too many variables to say exactly what the average detection range is. But for Wi-Fi itself, the average range from a cellular device to Wi-Fi is roughly 150 feet. Are there any more questions out there today? Okay, so the question is, I understand that MAC addresses can be used for origin, destination, and time travel. Travel time, forgive me, we're not detecting DeLoreans. What you were saying in the presentation about determining delay at the intersection, how does that work? Well, because we can use signal strength as well as the unique MAC address, we can determine when the vehicle is actually stopped at an intersection, which allows us to understand what the dwell time is for that vehicle at that intersection. Okay, so 100% heading to destination, 20% from here, 40% from there, etc. How accurate is the data if not every vehicle has a Wi-Fi device in the vehicle? If basing traffic signal manipulations on this data, not sure if it would be completely applicable. So, you know, just I guess to really touch base on that, obviously you're going to have trending information. So, you know, looking at it, this data based on signal strength and to the sensors is allowing us to be very accurate about where the vehicle is in relation to the sensor. And since it is unique information, we're certain that obviously this is the same vehicle throughout the entire corridor. So that said, the travel time can be very accurate. Once again, a traffic manager can use multiple other tools or reporting to make decisions on signal timing. However, with using StreetSmart, there will be enough information to where you can look at the trend before, and you're going to be apples to apples with trend after numbers. So clearly, this is a good way to verify if there is a positive change in that direction with very accurate data as far as from travel time. Can we have count data with this system? If so, what is the accuracy? That's where GRIDSMART's really going to come in with very accurate counting at the intersections. And so what we're going to do is we're going to give you a better understanding of the flow of traffic with StreetSmart. I just want to be really clear that StreetSmart isn't geared towards counting. And so, that's a big, that's something where I would definitely recommend looking at GRIDSMART at the intersection for a much more accurate counting system and to collect data there, plus also the visibility of what's going on at the intersections. But StreetSmart's going to help you with understanding the flow of traffic past the intersection. Not really going to focus and gear towards counting using the system. You will be able to see what counts are or how many unique devices were recorded per each one of the sensors. However, that's not going to be used for an accurate counting system of overall traffic. Roger asked, what is the cost of typical installation, intersection hardware, and associated software? Roger, I definitely want to get with you offline, and we can definitely talk about that. I will send you an email over after the webinar, and we can go over that for sure. How can we learn the installation crater? Help me understand what, maybe that was a typo there. Okay, so how can we learn the installation criterias? We actually do have an installation guide available, and I can definitely send that over to you with all the information after the webinar. Are there any other questions from anyone in the audience? Feel free to use the chat or also the Q&A section. Okay, it doesn't look like any more questions are coming in. Thank you, everyone, for attending today. I really appreciate taking an hour out of your day to listen and learn more about StreetSmart. Once again, you can email me if you would like a one-on-one demo and dig into any of the features in more detail, or would like a better understanding of the overview of how StreetSmart works, or the application for a specific area. Thank you again for your time today, and that is the end of our webinar.